All right, so let's talk about example 3. It says Mr. Quan takes the bus to get to Highline College. He has an Orca card that has $99 on it. The bus fare is $2.75 one way, so that means that he ends up spending $5.50 per day on bus fare. If you don't know what an Orca card is, it's basically a blue card that you can refill with money so that you can take public transportation in King County and I believe Pierce County. It works there as well. So part A says, how long will it take before Mr. Quan runs out of money on his Orca card? And in this scenario, we're assuming that Mr. Quan doesn't add any additional money to his Orca card. So we know that we're starting off with $99. And each day I spend $5.50. So if I wanted, I could make a little table. And so this represents the number of days. And the output variable represents the amount of money on Orca card. And so initially, to start off with, on day 0, I have $99. And then if I go the next day, I'll end up spending $5.50. So if I subtract $5 from 99, that would leave me with 94. And then if I subtracted an additional 50 cents, then that would be 93.50. And then the next day, if I subtracted $5, that would be $88. And then I could subtract off that 50 cents. So it would be 88. And I could continue this pattern and figure out when it would be 0. But if I just keep on subtracting 550 like that, that's going to take me forever. So maybe pause the video and take a minute to think about how could we do this where we would be able to figure out that number. So if we do some long division, kind of like we did in the previous examples, we know that 55 goes into 99 one time. And 55 goes into 440, let's see. Eight times. So what this number indicates to us is it should be the case that after 18 days, we are left with $0 on our Orca card. So, we want to write that in a full sentence. Okay. Now it asks us in part B to create an equation that models that scenario. And, we already talked about the general form of an equation is y equals mx plus b. And so our variables here are y and x are not going to change. Our goal is to figure out what m is, which is the slope, and what b is, which helps us figure out the y-intercept. And so recall that m represents the constant rate of change. So in this scenario, we know that every day Mr. Quan is spending $5.50. So let's go ahead and put 5.5x and then add. Remember, here we made this table, and so our y-intercept is 0, b. So that means that this value here is our b value. So I'm going to add 99. Let's just do a check really quick to make sure that this equation makes sense. It should be the case that, because remember this is my input and this is my output, If I plugged in something from this t table up here, it should give me the correct value. So let's try plugging in 2 and seeing if that works. So y equals 5.5 times 2 plus 99. If we created the correct equation, it should give me an output of 88. Let's see if that happens. 5.5 times 2 is 11. So if I add those two numbers together, that will give me 110. I want you to pause the video for a second and think about, what did we do incorrectly with our equation? So hopefully you've thought about it and paused the video. The thing that we did incorrectly is that there needs to be a negative sign in front of our slope value. So this is actually the correct answer here. And the reason that it's negative is because Mr. Quan is spending $5.50. So that means that the value on the card is decreasing. And Part C asks us to sketch a graph of the scenario above by plotting the Y-intercept and the X-intercept, then connecting those points. So we're going to see how that negative plays into what the graph looks like. Notice it also says we haven't formally defined an X-intercept, but one way you can think about it is it's the point at which our graph crosses the x-axis. So in this example, we're not given a grid, so I'm just going to quickly draw something like that. And so these are our y values, these are our x values, and remember in this case, y represents total amount on Orca card. And our x values, or our inputs, are the number of days that pass. And we already know from our table what our y-intercept is, and our y-intercept is 0,99. So maybe I could go by 20s here. So our y-intercept is just going to be below 100 right there. And we've figured out that after 18 days is when we're going to run out of money, or in other words, this here represents our x-intercept if we created an ordered pair out of that. So I'm going to go by, let's see, we could go by 3s. So 3, 6, 9, 12, 15, 18. So I'm going to plot my x-intercept there, and I'm just going to connect those dots now. Notice that I didn't go extend past either of those points because I don't know if I started with more than $99, and Orca cards don't allow you to go into a negative balance as far as I know. So our line is not going to extend past those dots. And this is our x-intercept. I'm just going to abbreviate. And this is our y-intercept.